Okay, let me post the social media. Alright. Okay, so we are going to develop some Sigma rules today. So you can see I have the root account with the PowerShell. And what are we going to be developing is, of course, for the ODDD. Actually, you can see that yeah, you can see that there is already some stuff for the sysmon, which is kinda cool. And some of them, as you can see, are created by this guy, which actually took my rules, and I'm happy that he included me in the autos, so that's cool. So yeah, this is for the sysmon, which was developed originally for the ODDD. I haven't tested it, the sysmon for the Linux yet, but we will see in the future. So today we are going to, let me quickly scan through those. Nothing. Okay, and this is related to loading arbitrary code into processes. Okay, so I guess we can develop rule for this, which is loading kernel modules via insmode command, right? Let's run uncoder.io. Let's grab some template. Let's actually grab the from this one. I guess this is related closely to what we are going to do. 7.4. Okay. And yeah. So we are going to look for the loading of the kernel module with the insmod command, and we are going to use the Atomic Red Team by the Red Canary. Okay, I was doing some stuff in the meantime. Okay, so been testing this, so let's do the cleanup. Okay, that's fine. And let me show you what also I have done, which is has become root for now. Oh, not this one. Apologies. Wrong command. So I have decided to go with this broad rule for the ODD, which will look every XCVE. So yeah, this will capture lots of lots of events. I mean, right? So we got the ODD rule with the key run. So let's actually invoke. Let's get the prerequisites for the test. This ID corresponds to the ID we have seen on the website, right? This test requires elevated privileges. That's why I'm running it as a root. Okay, so the get prerequisites created some binaries, make some files, so we are ready to execute our test. And we could invoke the test like so, right? So let's just invoke it. Okay, so it has executed. And let's look at our logs. Okay, grep insmod. Right, we need to provide the key as well. Let's exclude the grep from the search. I guess let's actually use the I switch as well. Okay, not in this position. One more time. Right. So this will be creation And this is the execution, right? So in this situation, we can use this or this or this, right? Yeah, let's look at the logs one more time. And add our test. So yeah. Let's try doing something with what we have obtained. So in this, at this point, I'm deciding actually which event to choose. The path one is interesting because it relates to the files that were accessed. But it does not provide us with the information what was loaded, right? But I guess you can correlate it in the same solution. So that's why I think about the exe CVE. Right. Or syscall. So let's try writing this. Loading of kernel module via insmod com. We remove the UID. UID. Yeah, and date. Let me see. Actually, quickly, what's okay? And let's go to the miter 2. So we can just cover this, and later I could also include more tests, right, in the atomic red team. But let's just focus on this one test, to cover this one test. All right. Let's copy something from the miter attack and let's modify it. Okay, so it detects loading of kernel modules with instant command. LKMs are pieces of code that can be loaded and unloaded into the kernel upon demand. And of course we take the reference. And this one. Looks fine. Let's grab something more about the insmod command, which is always appreciated. Alright, so let's take a look at our events again. Yeah. The problem with the execve command is that you need to be aware of the position, right, of the command. Imagine that for some not for some reason, but adversary managed to obtain the root account, right? So he doesn't need to use the sudo. So immediately the insmod command can be moved to the A0 position, right? Here it is executed like that, but if we were specifically looking for the sudo at the A0 and the insmod at the A1, it would fail if the adversary would use the root account, for example. So it is the question of making the rule more resilient, right? Let's go with the execve. So I would go with something like that. or with the path. Syscall is not bad as well. Let's go with the Syscall. Can also grab the exe. So let's take a look. So we're looking for the Syscall. Command is in mode. It is executing this binary. I guess we could also look for the K mode. Which is being called. Yeah. Can see. It looks fine. Yeah. Let's actually check this within the Sentinel. See how well it performs. Right, so we can use the syscalls. Middle local time. Okay, so it looks about alright. I have executed this 3 times. I guess we could do the cleanup. Got the prerequisites. Right. And we can actually, let's do something else. Let's take this logic and let me take this off screen and implement the analytics for it, so we can see the alert happening, right? So I'm not going to, let me actually show you this quickly. I'm not going to map entities for now. Let's leave it with the basic information. In the real world, you would want to obtain more information from it and map some entities that would allow Sentinel to correlate this alert with different alerts based on user, for example, or the host, or stuff like that. Let's call it something like that. Let's provide some more details. Right, and the tactic is persistence, privilege escalation. The logic. All right. Let's run it every 5 minutes. Some basic stuff. So you can see. All right. And let's now execute this. Let's hope that it will run soon, because the first run within Azure Sentinel is not always there is no like the time period guaranteed for the first run, as far as I remember. Let me load the incidents view. Well, let's see. Yeah, so we could also implement checking for those commands. Yeah, there is a possibility that the first instance of will be not reported, right? Because of this really weird thing that the first like execution is not set in the like in the Splunk. You have the information when is the next execution of the query, and all is fine. Let's hope that it will be caught soon, because if not, the demo is then not successful. can see the local time. Yeah, this is the execution. But whether the alert will be performed, that's the question. I guess we can do the cleanup and then give me a second, guys. Okay, sorry for that. Here we did the cleanup. So we can get the prerequisites again. Not sure whether the normal execution will also get the prerequisites by default, perhaps. Right, so we can now have the prerequisites. You can see the time. Okay, so the test is done. 24, something like that, past 4 p.m. So let's just wait a little bit for the alert to appear. So yeah, those are the events. I guess we could do something like that. Then we would implement the other commands, right? I'm referring to the stuff that you can find within the attack by MITRE, right? And this would be actually not bad. I guess on the next stream we can extend this rule and make it better, right? By implementing those different commands. So the question is why it's not working, or we need to be more patient. Actually, it's really funny because this is it is always better to not see many stuff in your sock, right? The more alerts you have, the more work your analysts have. Alright, so this is it. So this is something that we wanted to see. Yeah, and this thing which I told you that we do not have the entities set up, which means that the Sentinel will not provide us with the investigation graph and the automatic correlation on different alerts is not here, right? So yeah, that's actually pretty neat. Let's view the details of this incident. We got tactics, everything, severity. Can write a comment. Right, that's good. You can see the alerts, you can see, let's see the events. This is what you would want to see as an analyst, right? So this is the raw event. You can see the computer, the host, a timestamp ID, some PIDs, UID, AUID as well, and the work of analysts would be to invoke different sysrug message contains to enrich the alert and get as much information as possible from this event, right? I search for the same timestamp and the ID, and we got many different events, some path events, some proc title events. From the exe CVE we can find out what was loaded actually, right? So you could get this information and write it as a comment, right? In our alert. Some different events. What libraries was loaded. Proc title would provide us after decoding with the full command that was executed. yeah, syscall is providing us with the user the information about was it successful or not. What syscall was executed. Yeah, as you know, I would like to correlate more events within our original correlation rule, but for the sake of this example, I ran quickly through it without making it like better or implementing correlating more stuff, because at this point we got the detection right. Now the question is to make it more resilient and to correlate as much stuff as possible from different events. Well, I'm talking about the ODD, of course, at this moment. Like I told you many times before, you have, in our case, we have this many events, 6 events for this one action, and we can correlate some information from that to our alert to make it better in terms of correlation with different alerts, and to provide more enrichment to our alert for the analyst to make their work easier, right? Which is like really good if you are thinking about your SOC in a mature way, right? Because writing alert that works is all good, right? But the next you need to enrich it and correlate with different stuff. Perhaps you will find other interesting stuff that you can use to make the alert better, right? For example, this is just an example, right? We could correlate CWD event, and it was determined that all alerts from the TMP are determined as false positive. That's just an example, right? In the real world, you wouldn't consider this as a false positive, but for the sake of this, we can consider this as false positive. So we can correlate this event and discard all the events that come from the TMP. So that provides us with the more granular approach, right? More filtering. We can filter out more false positive. Okay, and let's look one more time at the rule. So we got the title, some description. I have used, as you can see, the MITRE ATT&CK technique to write this. Some references, log sources, and then the logic and the fields that we are looking for. Level attacks, false positives, and ID you can generate later. So yeah, and the next step for this would be to implement other commands and make it more resilient, right? Okay, I guess this is it for now. This was a quick stream trying to make it like faster and more relevant, not much obsolete stuff, just straight to the point I guess I can try to uploading this to the GitHub after some cleanup. Yeah, and those are the events that we have found. And the incident, you can see we have generated the incident. Okay, and this is the second one that we were waiting for. Yeah. So it's working indeed. And that's good. That's good to see. Okay. So I'm going off for now, I think. So thanks for watching, guys. Some quick Sigma rule, then converting it to the Azure Sentinel and checking whether it is working, right? And we have utilized the Atomic Red Team test we used the manual approach to test for it. Actually, we could check show details what the test is doing. So it is executing this command. Yeah, and what the get prerequisite command is doing. Okay, so thanks guys for watching. I guess I see you next time. Cheers.